When burying rigid metallic conduit, or RMC, concrete encased underground in an alley, it is essential to adhere to the National Electrical Code, or NEC Table 300.5 for proper installation and safety. The primary concern is the minimum burial depth required to protect the conduit from physical damage, especially in areas subject to vehicular traffic. NEC Table 300.5 specifies minimum burial depths for various wiring methods and installation conditions. Determining the correct category is crucial for compliance. In the scenario of an alley with asphalt surfaces where rigid metallic conduit is to be buried and concrete encased, the key consideration is whether the alley is considered a public way and subject to vehicular traffic. If the alley is accessible to vehicles, it falls under the streets category of NEC Table 300.5. Therefore, the minimum burial depth for rigid metallic conduit in concrete encased underground in such an alley must adhere to the streets category, which requires a minimum depth of 24 inches. Ignoring this requirement and opting for the trench, under 2-inch concrete category, which allows for a 6-inch depth, would be a violation of the NEC and could lead to potential damage to the conduit and electrical hazards. The rationale behind the streets category's deeper burial depth is to provide adequate protection against the weight and impact of vehicular traffic. Concrete encasement provides additional protection, but the minimum depth ensures that the conduit is buried deep enough to avoid being crushed or damaged by vehicles. When planning an installation, it is always best to consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. This is especially important when dealing with underground electrical installations, as there may be local amendments or interpretations of the NEC that need to be considered. Let's delve deeper into the specifics of NEC Table 300.5 and its application to different scenarios. NEC Table 300.5 provides a comprehensive guide to the minimum burial depths required for various wiring methods and voltage levels. The table is organized by voltage level and installation type, making it easy to find the correct burial depth for a specific application. The table is divided into several categories, each representing a different type of installation. These categories include direct burial cables, rigid metal conduit, intermediate metal conduit, rigid non-metallic conduit, and others. Each category has its own set of minimum burial depths, which vary depending on the voltage level and the type of installation. For example, direct burial cables typically require a deeper burial depth than rigid metal conduit, as they are more vulnerable to physical damage. The minimum burial depths specified in NEC Table 300.5 are based on the assumption that the wiring method will be installed in a manner that minimizes the risk of physical damage. This includes proper backfilling, compaction, and the use of warning ribbons or other markers to indicate the presence of underground utilities. The table also includes footnotes that provide additional information and guidance on specific installation requirements. These footnotes should be carefully reviewed to ensure that all applicable requirements are met. In addition to the general categories, NEC Table 300.5 also includes specific requirements for installations under roadways, driveways, and other areas subject to vehicular traffic. These requirements are more stringent than the general requirements, as the risk of physical damage is greater in these areas. As previously mentioned, the streets category requires a minimum burial depth of 24 inches for rigid metallic conduit in concrete encased underground. This requirement applies to any area that is subject to vehicular traffic, regardless of whether it is a public street or a private driveway. The term concrete encased refers to a specific installation method in which the conduit is completely surrounded by concrete. This method provides additional protection against physical damage and corrosion, and it is often used in areas where the conduit is exposed to harsh environmental conditions. To properly concrete encase a conduit, the concrete must be of sufficient thickness and strength to provide adequate protection. The concrete should also be properly mixed and cured to ensure that it is free of voids or cracks. The NEC does not specify the exact dimensions or strength requirements for concrete encasement, but it is generally recommended that the concrete be at least 2 inches thick on all sides of the conduit and have a compressive strength of at least 3,000 pounds per square inch. When installing rigid metallic conduit underground, it is important to follow all manufacturers' instructions and industry best practices. This includes properly preparing the trench, installing the conduit at the correct depth, and backfilling the trench with suitable material. The trench should be wide enough to accommodate the conduit and any necessary fittings, and it should be deep enough to provide the required burial depth. The bottom of the trench should be smooth and free of rocks or other debris that could damage the conduit. The conduit should be installed in a straight line, and it should be properly supported to prevent sagging or movement. All joints and fittings should be properly tightened to ensure a watertight seal. The trench should be backfilled with suitable material such as sand or gravel, and it should be compacted to prevent settling. A warning ribbon or other marker should be placed in the trench to indicate the presence of underground utilities. In addition to the minimum burial depth requirements, the NEC also includes requirements for the type of conduit that can be used underground. Rigid metallic conduit, or RMC, is a popular choice for underground installations due to its strength and durability. RMC is made of steel or aluminum and is designed to withstand physical damage and corrosion. It is available in various sizes and thicknesses, and it can be easily cut and threaded to fit any application. Another option for underground installations is intermediate metal conduit, or IMC. IMC is similar to RMC, but it is thinner and lighter, making it easier to work with. IMC is also less expensive than RMC, but it is not as strong or durable. Rigid non-metallic conduit, or PVC, is another option for underground installations. PVC is a lightweight, corrosion-resistant material that is easy to install. However, PVC is not as strong as RMC or IMC, and it is more vulnerable to physical damage. Therefore, PVC is typically only used in areas where it is not subject to vehicular traffic or other heavy loads. When selecting a conduit for underground installation, it is important to consider the specific requirements of the application. This includes the voltage level, the type of soil, the presence of moisture, and the potential for physical damage. It is also important to consult with a qualified electrical inspector or engineer to ensure that the selected conduit is suitable for the intended use. In summary, when burying rigid metallic conduit concrete encased underground in an alley subject to vehicular traffic, adhering to the streets category of NEC Table 300.5, which mandates a minimum burial depth of 24 inches, is paramount. This ensures the conduit's protection against physical damage from vehicular traffic and guarantees compliance with the National Electrical Code.